And we're very grateful now to have Fred with us. Hi, Fred. How are you doing?
I'm doing well. How are you?
Excellent. Thank you. It's always a privilege to have you on with your direction about the use of FreeSwitch and Commonilio together. And we all appreciate having Daniel on earlier. So it's turned into a bit of a Commonilio fest. And I see that you're wearing the hat, Fred.
I am. And of course, it's a downgrade from me, but he also has better hair, so it doesn't need the hat all the time.
It's a fine looking piece of Commonilio hat. Well, thank you very much for joining us, Fred. We're grateful for you coming along and sharing your wisdom with us. I'm gonna just let you carry on, really, and say thank you. And we're looking forward to what you have to say.
Awesome. And you have my screen. Which one is mine, right?
Yes, it's going to come up right now.
Look at that. There we go. All right. So today I'm going to talk about outsourcing to Commonilio. And, you know, we've had some discussions and some other talks today about what Commonilio is and, you know, different things that you can do with Commonilio. So my presentation is going to be more of why. You know, you have FreeSwitch. FreeSwitch is doing things. Why use Commonilio if FreeSwitch is handling everything that you do? And we all love FreeSwitch. So that is the goal of today. So the agenda will be a brief talk about what is Commonilio, and then we'll talk about using Commonilio as a SIP edge router, using Commonilio for registrations, offloading mid-registrar, basic calls, and that's like one slide, so very basic, and then bridging. So first, the most exciting part of the talk is my daughter, and she's just the most amazing thing in the world. My name is Fred Posner. You can reach me at qxork.com, since there's some telephony geeks here. That doesn't spell anything, but it's letters that I don't have to pronounce. Hard consonants. QXORK. And I'm on Twitter at Fred Posner, and then I love Matrix. So if you want to reach me, Fred at matrix.lod.com. All right. So what is Commonilio? And more importantly, of course, is comma what? So Commonilio, in case you're having trouble pronouncing it, that's my go-to method of saying the words. And Commonilio is modular based, small footprint. It's an open source SIP server. Been around for a long time, 19 years. We just celebrated its birthday virtually, which was awesome, and disappointing to do it virtually instead of in Berlin. It can handle thousands of call setups per second. It's module based, again, which gives it a very small footprint. You only load what you need. And especially with the attraction of SignalWire, Chemi, which is our embedded language interface, allows you to use your favorite language to write Commonilio logic instead of using Commonilio scripting. And when I say favorite, as long as one of your favorite languages is JavaScript, Lua, Python, Python 3, Ruby, or Squirrel, then Chemi is the right choice for you. So some of the main features of Commonilio are ability to handle registration. So it's a registrar server, a location server, a proxy server, SIP application server, a redirect server. It handles UDP, TCP, TLS, SCTP, IPv4, IPv6, and it's handled those for over 10 years at this point. WebSockets. It's very stateless, which allows it to work really, really fast. And, it's a load balancer, and it's easily scalable. So the big reason is, why would you like this kind of product? Well, think about everything that we've said here. It's all geared towards SIP. All of the things that you do with FreeSwitch, in fact, some of the really fun ones you do are mostly media, right? And so this is just SIP. And so since it's just focused on SIP, it can do a lot very, very quickly. Commonilio is not a SIP phone, though. It's not a media server, and I have that starred because there's a couple modules that let you do some fun things with media, and we can proxy media, but we're definitely not a media server in of itself. And it's not a B2B UA, but of course, FreeSwitch is all of those three things. So use them together and do really awesome things. So the first aspect is security. So let's offload some of the, or outsource some of the security features of FreeSwitch to Commonilio. So FreeSwitch has great security. Okay, and this is your typical deployment. Here's FreeSwitch and got it all there. So how are we handling security? We're probably handling security with access control list or scripts, maybe fail to ban, hopefully a firewall. And FreeSwitch itself does have great security, but now using a SIP edge router frees FreeSwitch and the resources that FreeSwitch allocates to doing security and lets it handle more calls, lets it handle more media, lets it do more. It frees those resources so that FreeSwitch can do what it does best. And just by putting a Commonilio in the mix, you can gain access to those resources that you would have already lost. Right? So let Commonilio handle the security. And Commonilio can handle security in more unique ways as well. It can handle all of your IP-based ACLs and things like that. You can have it handle both your LAN and WAN traffic, right? It can put in your business logic. We can check for IP, host, user agent, any combinations that you want. These are the fun things that Commonilio can do, is that you can get really creative. So instead of just saying, okay, I want to block this IP, maybe you do want that IP, but you only want this IP to be able to access you at 2 calls per second. Commonilio can help you with that, right? If I get too many calls per second, I want to block this IP. Or if I get too many registrations from this one IP, I want to block it. If I'm not getting this user agent, I want to block the traffic. So anything that you can think of, we can do. We can block SQL injection. Any kind of custom responses or even no responses. Now, one of the things that I really love about Commonilio compared to, let's say, FreeSwitch handling of things is instead of returning an error message and then letting people try again, we can just ignore the response, right? So we just ignore it, just drop it. And that's really good when you start getting these option pings because they just move on instead of going, okay, I have a PBX, let me go and attack it. So as a SIP edge router, you can offload that to Commonilio and let your FreeSwitch do more with less. So some of the modules that we use to make a SIP edge router are permissions module, Pike. We have our own stir shaken if you'd like, which allows you to use it globally on your network. The SEC filter module and pipe limit, all those together, as well as H-table and different other modules that you'd like to put in. But those are some of the big ones that you would use for security. I'm leaving lots of room at the end for questions because that's usually the best part. So let me move on to registration. Registration is a great feature that FreeSwitch does, right? It's how you have the users. And one unfortunate consequence of having a lot of users is there's a lot of SIP traffic to your system for those users, especially if it's NAT based, right? This is where you're losing a lot of overhead. So, you start getting into a few thousand use FreeSwitch, and then, you'll start seeing your CPU stay up just because of all this user registration and, other kind of resources, and your FreeSwitch is just juggling a lot of balls. So let's take one ball and give it to Commonilio, right? So Commonilio and FreeSwitch are better together. 3 main ways that we can handle or help FreeSwitch in this regard. One is just completely outsource all of the registration to Commonilio. 2 is doing a simple pass-through. And then 3 is doing mid-registration or mid-registrar. And let's take each one by example. So with registration, the example that I like to give is think of Neo when he's just handling all the punches and he's just doing it one-handed because he's just that awesome at it. When you are that focused on SIP, and Daniel hit on this earlier if you caught his presentation, Commonilio can do tremendous volume of SIP traffic because all it does is SIP, right? It's all it's worried about. So it's very focused. As an example, if you had just a small system with 4 gigs of memory, just a few cores, it's not unheard of to have hundreds of thousands of users registrations and still be in pretty low CPU. It's just easily handle hundreds of thousands of users. And it's extremely easy to scale just by either adding a little bit more resources to that box or another box. The negative of handling all of your registration to Commonilio is that this does need to change how you've maybe designed your FreeSwitch system, right? Because instead of doing user-based, just bridge to this user, you're going to send it to an endpoint at Commonilio. So there's a little bit of difference in terms of design of your FreeSwitch dial plan and everything like that once you implement this method. So it's easier if you do it from the start. When you're transitioning to this one, this aspect of registration does take a little bit more planning. But then we also have simple pass-through. And I like to think of this as a customs and immigration type of analogy here, right? Where Commonilio checks it out. If it's good, then you could go through and then you could go on to the FreeSwitch and go from there. This is also really good if you wanted to combine it with SIP edge routing and put your FreeSwitch totally behind your firewall, give it private IP, don't give it public anything. Commonilio can do a domain and translate that domain to an IP, so you get multiple FreeSwitches, which is very common, and go from there. We can also track failed registration, so we're just passing it through. So we know that this user doesn't exist. Let's never let FreeSwitch get it again. Okay, it's sending it to a bad domain. Let me not bother FreeSwitch with it. I'm just going to reject it. Okay, too many CPS. I'm going to block it from FreeSwitch. I'm still going to let FreeSwitch handle the number of registrations. It's going to handle it all. I'm just, blocking it, saying, no, this is from a bad place. We're not going to let it through. If you're using a database for your username and passwords with FreeSwitch, Commonilio can pre-auth using that same data source and then just send it to FreeSwitch when it's good, and that allows you to not even bother FreeSwitch with bad registrations. So simple pass-through is really good. A common deployment might be to have multiple FreeSwitches, as many as you want. Let's say you had a dozen. You can have, 1 or 2 Commonilios in high availability and go ahead and pass that on to FreeSwitch. Again, just with that simple domain to IP mapping, you could keep all of those FreeSwitches behind your firewall and not expose them to the public internet whatsoever. Now, mid-registrar is the third way that you would handle most of your registration that you would like to offload to Commonilio. It's been available in Commonilio since 2010. There's a couple of ways of doing it. One is with the UAC module, and the UAC module within Commonilio allows you to send user and password and registration and have those work just pretty much off the bat. Another way is to use HTable. Okay, and you can combine this kind of with the pass-through model, right? So an example might be that the phone registers, through the internet. Commonilio is just watching, right? When Commonilio gets the registration, it tells FreeSwitch, all it does is change the contact header and, just a little bit of the other headers, so that as far as FreeSwitch is concerned, the endpoint is Commonilio. It's, the Commonilio's IP. We gave it its own, username there. And so it passes it through, it registers, and Commonilio tells FreeSwitch, okay, you know what? Here, give me an expiration date or expiration time of an hour. And FreeSwitch goes, oh, yep, everything's good. That's okay, because it's, the same username and password that the phone's sending. And so Commonilio sees that it's a 200 okay, and then it sends it back, but it shortens the expiration time to whatever we need for the NAT. So let's say this phone is NATed and we want to keep the firewall open, so we'll make it 60 seconds. So we have PBX at 1 hour, the phone to the Commonilio at 60 seconds, and then when it comes through, the next register comes in. It doesn't even send it to the PBX. It just sends it back. Commonilio goes, okay, it's within the hour. It's the same port and IP and everything. It's okay. And it just keeps that open. And you've now just saved, your FreeSwitch, an hour's worth of registrations every minute or everything like that. Everything works great. When there's an incoming call, Commonilio's already kept what port and IP. It changes all those headers and all the calls just work as normal. And so mid-registration is a fantastic way of helping your FreeSwitch grow when you start getting a ton of users. You can outsource basic calls to Commonilio. And when I say basic, I put those in quotes because any call that you would want a special FreeSwitch feature, such as, FreeSwitch is doing the recording, or it needs to be a conference call, or it needs to be something that can be transferred later on, or you're doing special things or anything special with the FreeSwitch dial plan or something like that, those still need to go to FreeSwitch. But let's say I'm just doing extension to extension. All right, just have that go right through Commonilio. Right, that doesn't need to bother FreeSwitch. It's just Bob calling Alice in the office. So keep it simple. If you don't need FreeSwitch, don't send it to FreeSwitch. If you need FreeSwitch, always send it to FreeSwitch. So sometimes simple outbound calls that don't need to be recorded or anything like that, those can go straight out. Just send them right out to the PSTN. Don't bother FreeSwitch. And then other calls inbound calls that have to go through an IVR or that might have to, be transferred or use PBX features, definitely go to FreeSwitch. But basic calls, keep it simple and just, send it to the user direct. And then the last thing I wanted to talk about, which then gives me the time for questions, would be bridging. And so some of the greatest things that Commonilio does is its ability to bridge. And you can outsource that to Commonilio. So FreeSwitch, for example, with TLS. So, you want to add TLS, that's a lot more overhead for FreeSwitch, right? Can it do it? Yes. Can it do it really well? Yes. But it does it at a cost of CPU. It does it at a cost of memory. And you could transfer that over to Commonilio. So Commonilio can handle all the TLS and then just send it to FreeSwitch as UDP. If everything's UDP on FreeSwitch, you can do a lot more things. So I can have UDP, TCP, TLS to my Commonilio and then send it all via UDP to FreeSwitch. I can do WebRTC to Commonilio and then transfer that via SIP. I can bridge IPv6 and IPv4. Keep it simple on FreeSwitch. Just do IPv4 and then have Commonilio handle a ton of different IPv4 and IPv6 and all that, and just bridge it to whatever static IP you want on the FreeSwitch side. I can also convert SRTP to RTP with RTP engine, which Commonilio will control for you. That works hand in hand with TLS, right? And that just keeps FreeSwitch, more efficient. Handle many more calls because I don't have to worry about SRTP and TLS as well. And those kinds of bridging. So some examples might be that a TLS call comes into Commonilio, sends it via UDP. SRTP comes into Commonilio, but as far as FreeSwitch is concerned, it's just regular RTP. Commonilio will handle bridging and send it out to the internet. So your public internet is still encrypted, but the LAN side is just fine and dandy. And you can also do that with IPv6. IPv6 call comes in, Commonilio sends it to FreeSwitch via IPv4. Could also be WebRTC to Commonilio, and then SIP to FreeSwitch. Just allowing you to keep your FreeSwitch as simple as you can handle. And those are the basic functions that we would like to, if I did correctly, I should have 10 minutes, 9 minutes left for questions. For more information, please go to commonilio.org. It's a great website with full of resources. You can join our mailing list. We have a matrix channel, IRC, because again, 19 years old, but again, FreeSwitch has IRC as well as Slack. So come on. But we have QXORK for me if you want to reach out to me directly. If you'd like better videos, look at the Commonilio World channel on YouTube. And with that, I would love to hit any of your questions. Let me look through the chat and go from there.
We appreciate that, Fred. Thank you very much. And just before we get any members of the audience asking questions, let me ask you a question, Fred. How many ClueCons is this for you?
I'm a late starter. Let's see. I started at Chicago.
That doesn't actually rule a lot out, Fred. They're all Chicago.
Well, that is funny, isn't it? Let's see. I don't know. I want to say at least 7.
Yeah, a good number. That's excellent. I think you maybe started a little bit earlier than me, but it's very good to have you along. And I was going to say each year, but we're doing more than one a year now. Each time you come and speak at ClueCon, you bring some very valuable information about the interaction between FreeSwitch and Commonilio, for which we're grateful. If you do have questions now, you can click the raise hand button, and that will highlight you to us, and we'll unmute you, or you can unmute yourself and you can get to ask Fred Posner a Commonilio / FreeSwitch based question. Who's our first?
Well, we're waiting for someone to make a question. The first Astrocon I ever went to actually had Brian West talking about FreeSwitch, and that's how I got into FreeSwitch.
How about that?
Yeah, so that's out in Arizona there. And
yeah, that was probably a first for Astrocon as well.
It was my first Astrocon. Wasn't the first one, but
was that the one where we went on Harley Davidson's into the desert afterwards, Fred?
A year before that one. Yeah.
A year before that one, right. Oh, okay.
Yeah. And then because the same place, right? A place so nice it went there twice. And then I'm a big fan of FreeSwitch. It's a great product, and one of the reasons why I like working with Commonilio in there is to, help do what FreeSwitch can do that other systems can't. And, offload that onto Commonilio. Let us help how we can as well.
Yes, sounds like a best of breed based solution that you're talking about there. Just while we're waiting for these questions to bubble up, there's a question in the chat about the little knockers that people are seeing. That virtual smoked glass you're seeing over people is because they've gone into do not disturb mode, where it says enable DND. And when they're in do not disturb mode, and I'm going to pick Jill as an example, I can click on Jill's knocker, as it were, and it sends a little signal for me to get her attention. Or I can go over here and do the same to Anthony, or who have we got here? Greg. I can knock on Greg's door. So Malcolm. I'm not sure whether it's Malcolm or Melson, but anyway, thank you for the question. That's what these things are about, indicating that people have gone on do not disturb mode. So who's got a question for Fred? We've got precisely 5 minutes, a maximum of 5 minutes for questions. So who's got one?
This might be a first for me. Interesting. I must have had
do you know what I'm thinking, Fred? I'm thinking that people who have come to see you in real life know that you have the cookies, and they're thinking, how can Fred deal with this on a virtual basis? And I have a suggestion. You can give out virtual cookies, Fred. If anybody asks question, you can give them a virtual cookie.
If you check your browser history, there's a cookie in there from me. No, I wish I closed the bakery, so there probably won't be any more Commonilio cookies. But
well, the thing about virtual cookies, they don't go straight on your hips.
they don't.
They're very diet friendly. But
looking in the chat here, yep.
Yeah, you got
testing
Afshin with a quick question on Afshin is asking the question about what's the best way to do HA Commonilio.
There's no best way. There's multiple ways. So my favorite way is if you have the ability to use UCARP, then UCARP is just a phenomenal tool. And with Commonilio being stateless, all you need to do is a virtual IP. So just have, if there's a problem with UCARP, it will automatically swing over to the, will swing your VIP over to the other node. And then within the script, you just shut down Commonilio and turn on the other one. And, calls continue to work because by nature, it's stateless. If you're going to start getting into things where you do need to keep state, you can use something like Redis, which will also be able to handle that kind of VIP. And if you use RTP engine within those two nodes, for example, as well with Redis, even the RTP will stay up on a failure when you bring it over, which is a lot of fun to play with. And you go from there. Or you could use, let's say, a second highly available Commonilio nodes to sync up with hash tables or database or however you wanted to do. So if you do need some stateful message retention, that's not a problem. You just connect to that, or you use a party, something like Redis that can handle that kind of failover as well. But UCARP is another is my default method when that's not there. There's some methods of using kind of an active node, and you could use Anycast. You could also use Monet instead of UCARP. Keep it in an active standby, or you could have 2 live running and then, let's say, use BGP or something like that. So many different ways you can achieve HA.
Okay. Thank you. Not strictly HA, but what about good old-fashioned round-robin DNS, if you've got a couple of Commonilios out there?
So to me, DNS is... I like to use DNS a lot when I want things to break because I just find that it tends to be my problem area. But yes, you can use DNS, and you could use SRV records or however you'd like, and use round robin in those aspects. Commonilio has a mechanism called DMQ, which is distributed message queue, where Commonilio uses special SIP messages just to keep each other up to date. Right. And so with that, you can have, and that works really well with Anycast as well. But you could use those type of things with round robin DNS, or however you weighted DNS, however you'd like to do it. I think in those aspects, taking it to the Anycast level is probably the way of the future, and will also give you benefits of if you wanted to deploy these at scale with Kubernetes or Docker or whatever virtual method is.
Useful advice. Thank you very much, Fred. And thank you for giving of your time here and your expertise, and lots of ClueCon love, not only to you, Fred, but to Anne-Marie and Jenny as well. Thank you to everybody.
Thank you so much. It's always great to see everyone, even if it's virtually. I really love this community, and it's an honor to spend time with you.
Thank you, Fred. All the best to you. Now we're going to pull Evan up now. He's our next speaker. Thank you, Fred. And hello, Evan. How are you doing today?
Oh, wait.
You got some audio now.
I am unmuted. I am great. I'm just sharing my presentation right now. How are you?
Okay, good. Now, recently, well, not recently, Evan, within the last few months, ClueCon attendees will remember your dangerous demo that included joining the conference from underwater. What was the fallout from that after that rather monumental occasion?
Well, interestingly enough, I did that with an old iPhone that was not waterproof. And so I had to encase it in a bunch of the plastic bags, which, while adding to perhaps the fun of it, really was a very frustrating experience. So I realized if I'm going to be doing underwater SignalWire calls, signal water calls more often, then I really should get a phone that is waterproof because it's just a pain to put in bags. So since then, I've got an iPhone 12 mini, and I'm very happy.
Good news. I'm pleased to hear that, Evan. We want you to be happy with your telephony devices.
We got to make sure that latency underwater, you have to work on the refraction as it comes down to it's really a good time. I wouldn't worry about it.
Exactly. And just a quick question. There's an Evan Jr. there joining the show. Good to see that young man.
This is a millipede coming in.
Ah, excellent.
Good.
Good news. I'm all for creatures with lots of legs as long as they're quite far away from me. In fact, it gives me an opportunity, just very briefly, to talk about a rather nasty centipede that we have here in Brazil that can administer a very horrible bite and put you in hospital. We have to avoid those. They come out in the rain.
Here in Los Angeles, not so bad.
Yeah, that's enough about multi-legged creatures. Evan, what have you come to talk to us about today here at ClueCon?
I've come to talk to you about the power of networks, really. And it's kind of a high-level talk about the networking and sort of the future of this kind of stuff, how SignalWire is doing things, how we sort of see the networks evolving in the world, and kind of why they are the way they are. So hopefully it'll be a little bit, it's sort of a fun talk about the ideas of how these things are planned and with the arrival of more advanced technologies, what the problem of the speed of light is going to be, and then basically how all of this ends up being something that is important to think about, because when you're building large collaborative platforms that span the globe, and as the ripple effects of COVID continue to wear on, and remote work is big, remote events are huge, how do you build services that actually accommodate 1 million, 1 billion people at once, potentially on them around the globe? And how do you make that an experience that everybody can, blend into the background, sort of Star Trek style?
Great stuff. Well, here's what I would say. When the CTO of SignalWire drops in to talk about this stuff, we'll get the notepads out and listen. So take it away, Evan, and please feel free to bring your slideshow up.
Yeah, you bet. Let me make sure that I have to hit play over here real quick. In a sec. Which tab is that in? Oh, there it is. Okay. Here we go. All right, great. So, yes, this is just the power of networks, right? So, for those of you who don't know me, I am Evan McGee. I'm the CTO and one of the co-founders over here at SignalWire. I give these talks quite a lot at a lot of conferences about different aspects of what we're doing here. And in the past, I've talked a lot about everything from wireless telephony, which was my previous job, working in MVNO space and wireless for long years. I used FreeSwitch to help power that MVNO on the Sprint network, which is sort of how I met Tony and how I met the entire, fine crew of people at ClueCon, and got really involved in everything related to it. And I can't say, it was awesome to hear Tony and Mike and Brian this morning sort of talking about the early stages and everyone's interaction with the community. For those of you who are somewhat new, it really is one of the best communities to be a part of. It's a very awesome group of people who are all pursuing amazingly interesting things. And I hope one day you're fortunate enough to get to work with as many of them as you can. And I have been. So it's been really wonderful. I wanted to kick this off by chatting for a minute about slime. Right? So I wanted to talk about slime. And many of you may know this. I don't know how many people, follow this sort of research or this sort of like chatter. But slime is very interesting stuff. Slime is super duper cool, right? Because it's very simple. And it's, as an organic, it really tries to follow the basic principles of all organic things, right? It tries to spend the least energy doing something, get there as fast as it can, and keep itself alive. So it doesn't spend extra energy reinforcing pathways that don't matter, right? You see that in brain science and all kinds of science where, just normal exercise, classic, if you don't use it, you lose it style of thinking. Slime is the perfect example of that. Classic, small, use it, don't use it, you lose it. And it is a fascinating subject to get into. And the thing I wanted to bring up was the fact that they did some research a little while ago talking about how slime makes networks, right? And so what they do is they realize that by following the basic principles of trying to get to food sources the most efficiently and the most economically, slime would start to build out a very concise, very high performance network of its own nutrient transport. And that was very, very cool, right? So as the slide says, sort of at the final design, it started sort of over here with the food sources and little tubes. And then the network design for cities and railroads it turns out humans have sort of optimized themselves along similar pathways. Down at the bottom here was an experimental setup done. I forget the exact researchers, but what they did was every little yellow dot there was a food source, and they simulated terrain with light and dark. So they put light down below. They put, light and dark to simulate where mountains were, so it's harder for the slime to go through, and basically gave it a lot of nutrients to sort of grow certain ways. And what they saw was that the slime mold ended up actually duplicating the Tokyo subway rail map pretty closely. When given the exact same inputs of where high density populations were, it actually grew to be very, very similar to what was organically done by humans anyway, which is a really interesting phenomenon, right? Kind of convergent design, the idea that people are inherently like slime mold in the sense that they try to find the easiest way to do things. Makes sense, right? It's all biology. It all kind of makes sense, but really sort of interesting thing to see. And the reason why I find that interesting is that really the world is sort of like a big 4-dimensional slime mold, right? So instead of having a little 2D plate we can kind of sit into and like follow the nutrients from left to right, maybe have a little bit of stuff, we're dealing with a lot of other things around here, right? We're dealing with terrain, a lot of ups and downs and valleys and peaks, and then distance. And that's the 4th dimension, right? It's time, because unlike slime, which can take 7 weeks to grow or do whatever else it wants, we are generally very concerned about getting places fast, doing things quickly. So you really have to figure out that 4th dimension of making sure you're optimizing for the time to grow one of these new little legs. Or if a leg is going bad or you don't need the nutrients at the far end, just to get rid of it and make sure that another one kind of pops up. So those are the kind of 4 dimensions we deal with. And it's really interesting, right? Because we get to play with all kinds of technologies. Now, traditionally, a lot of this comes with like fiber, right? Fiber is the number one thing that we use to connect all this stuff together. You can kind of see, straight as we can possibly get. It's not perfectly great, but it's not bad. But however, in the real world, you just can't connect everything with fiber. You can't lay it down. You can't blow fiber up and down mountains all the time. You have to get there with wireless, and wireless has its own set of problems, right? Coming out of this world, this was a very pertinent thing. So this is some research from the Center of Transportation from 2016 that I read a while back that was talking about basically doing fleet monitoring of trucks and that kind of stuff as they drive around. And the issue really was that they had a fairly good throughput rate and very low error rate as long as they had line of sight. But as soon as you started throwing hills, uphills, downhills, particularly like downhills and terrain blocking line of sight, you'd lose about 12% of all packets sent, right? It was a really horrible packet loss ratio and a really terrible experience because they were like, the wireless just gets absorbed by everything. So as people are moving around the globe and doing things, let's say you're talking on your phone, you're trying to, use SignalWire that works for your phone and suddenly you're driving around, all this is getting blocked, the signal's dropping. You can't do it when there's no signal around. So, these kind of things are very interesting because they show that while we have the ability to cover the planet and the ability to do all these things, it doesn't always work out the way you might think. Might be better that you will actually get less packet loss from something a little bit further away versus something that's closer, just based on terrain and line of sight and things like that. And then, of course, there's Starlink, right? And so Starlink is really interesting because of the fact that it actually bypasses a lot of these things. Now, one of the things I wanted to point out, and I'm sure a lot of you know this, right, is the speed of light in fiber is about 31% slower than it is in vacuum. So everyone asks, well, why is Starlink sometimes better or faster than normal just laying fiber or going straight, right? Well, first of all, you can't go straight, right? Going from London to Johannesburg generally goes around the coast of Europe and around all of Africa and back down again. Much longer path. And you're slowed down by about 30%. So, they've shown that once the full Starlink meshes up, or a similar style grid, I'm not trying to promote Starlink here, but just like a similar style low Earth orbit satellite grid, you could do, path from London to Johannesburg in around 82 milliseconds versus the current internet, which is 190 milliseconds. So that is pretty exciting, right? If you can't get to it by the ground quickly, well, then why not go to space and just shoot in lasers? Because you can go, the laser through the free vacuum of space much faster, much more exciting, much more Star Trek-y, which is, close to my heart then. That to me is very cool, right? It's giving us another avenue to get around the physical limitations of the world, right? And my background being in physics is also a very exciting thing to see us actually using the speed of light to do things. Now, naturally, Starlink's not there yet. This is all future stuff for them, but we're pushing towards it. The knowledge is there. It's just a matter of when we're going to get there. So that's very cool. Another thing on the physics side to think about, right, is just the speed of sound. And the speed of sound is approximately 1.125 feet per millisecond at 20 degrees Celsius. And yes, I intentionally mixed the units measurements there from imperial and not just to have fun. So I did that on purpose. My point of saying that is that the latency of something, when you're talking about video and audio communications, is extremely important. Why are these satellites important? Why is it important to get to Johannesburg faster? Why is it important to not have this line of sight issue? Well, the thing is, at 1.125 feet per millisecond, really the maximum latency from the VoLTE latency on wireless, they call for 100 milliseconds or less one way, and video 150 milliseconds or less one way. Or VoIP, really, I think is the generic one we all look at, is about 250 milliseconds round trip. Before latency becomes so noticeable that it impacts conversations. So you want substantially lower than that. That's the absolute maximum. And that maximum equivalently is about 1 Arc de Triomphe. So about 1 Arc de Triomphe worth of latency, so shouting from the top to the bottom, is really all you get in terms of how far away somebody can really be in the real world before you start to be like, that you're too far away, this conversation is too difficult. I would love someone to try this for me someday and just record what that sounds like, by the way. I don't know if you can actually climb to the top, but if someone has some access, please go give that a shot for me. So, how do we keep the entire planet, if possible, within 1 Arc de Triomphe of each other? That's a big ask, right? But that's the only way we're going to be able to actually collaborate on a worldwide scale, is by minimizing this as much as we can. And to do that, you're really going to need something like free space lasers, stuff like that, right? A global network of fiber and wireless is not going to quite cut it, right? So again, this is what we need, right? You kind of need something like that. You need to be able to go hop into space, go back over 90 milliseconds, far below the 100 necessary, not far, just, but that's pretty good. I'd say if you can get from London to Joburg and you do it in 90, that's not bad, or 82. Well, then how do I leverage this today, right? I want to use this stuff today. I don't want to wait until all these things are built, 5, 10, 2 years from now, however long they go. I'm not privy to their launch schedule. So right now we can do the best we can with something I like to call location-aware agnostic routing. What that actually means is you need to know where you are, where everybody else is, what everyone else is needing to do in a particular scenario, whether that's audio or video, and what the underlying network conditions look like between them, right? And that way you can use the intelligence of your application to say, hey, I want to find out a place where these people can go together to have the best experience. So let's say we have 2 people talking in Europe, they're in Ireland. And so they connect through a data center in Ireland, right? SignalWire, right? We run FreeSwitch as the media engine. So naturally everything comes in and we mix it together centrally. So all streams come in and one stream goes out. We want that to run in Ireland so they have the best possible experience. And then someone from Germany, okay, no problem. Ireland's probably still just fine. And then let's say 2 people from Bulgaria join. Well, now, it might be that the most optimal location for everybody is a data center somewhere in Frankfurt, because it's a little bit more centralized. Maybe the connections are a little bit better. So the conference then can kind of elegantly and elastically move over to Frankfurt and not have to be just trapped in Ireland. So everybody doesn't notice they've moved, but the continuation of quality is there. And that's a really important and very fundamentally powerful thing to ensure that everybody has a good experience. How do you leverage this right now? Well, you need large data centers, right? But here's the good thing about large data centers is they are everywhere, right? Here are just 2 of them I picked out real quick. Cloud Platform, Amazon Web Services, they naturally have things everywhere. Azure is also on here. I'm sorry, guys. I realized you've been here, I would have put the Azure data centers up as well. Similar sort of densities to around the world. You can kind of see it's a little bit of difference, right? The East Coast, East here, Amazon has some other stuff. Amazon has Cape Town, Google does not. Sao Paulo, everybody has. So a bunch of stuff, right? So that's great. These big cloud data centers basically enable it so you can use them as your backbone. They have invested billions and billions in compute infrastructure and bandwidth and uptime. And why not leverage that, right? It's gotten to the point now where that makes a lot of sense. You also now have the rise of near edge compute. Now, these aren't the big data centers from GCP or Amazon or anybody. These are the ones that are run by local data center providers. That could be someone as small as, I think it's like an Edge Express, the name of the company that has this map. But they want to be in every state, or all the states with a lot of population. And so I know Comcast was experimenting a while back, wondering if they could run in their unused data center space. Now they have in every single state, Kubernetes clusters that you could just load things onto. So why not have compute nodes and edge nodes in every single state. Why should any of my conversations in California lead me? I talk to Tony, and if he's in Florida or he's in Wisconsin, like, you should find the best place between the two of us. And then you have the true edge compute, right? So this is a picture, sort of an overlay of the very zoomed out macro level view of the number of 5G base station towers across the US. There are a shocking number in Illinois. I don't really know why there's so many there. Probably don't really understand that number, but the other ones really are. And those come down to neighborhood level, right? And that's the true edge compute benefit, right? When you start to have just generic, so the difference in 5G towers, like the 4G one, really is that the 5G towers at their base stations are really just like fancy little computers and small little data centers themselves. They can run things on those. They could run anything you want. They can run, just generic compute stuff. They can run nodes of SignalWire so that we can get media directly to the edge and then route that somewhere more intelligently, which is exactly how Apple did FaceTime when it first came out. If you all remember that FaceTime worked when nothing else did, it's because they had all of their gear right inside the cellular network in AT&T. So when FaceTime calls came, they wouldn't go into the public internet. They would just transit AT&T and back out again. And that's why FaceTime was the only thing that actually was successful for a number of years with the video chatting. We're looking at things like this, right? All of these have to come together in the future to make it so people can collaborate and more efficiently work with each other. And that's the power of these networks that's evolving. When you hear edge compute and that kind of stuff and all these things, there's lots of like applications for them. But for me, when it comes to communications, it's really about making sure that people are able to work and talk with people and that they can have that sense of immediacy where we can have, live concerts and music events that actually like can get to people in really sort of, profound ways where they can interact with them that feels like they're actually there, even though they can't be. Or loved ones, for birthday parties, as VR and AR come online, that's only going to rapidly expand how much data is pushed over these things, how much manipulation is needed, how much spread is needed. So, looking future facing on that regard is kind of very exciting. Whoops. No, well, there. Anyway, SignalWire right now runs in these data centers. These data centers right here are sort of the ones we have, our larger ones, right? And our goal was to allow a 50 millisecond round trip time from anywhere in the world, right? So we looked at the numbers of 250 milliseconds as a benchmark that we didn't want to get anywhere near. If we had to, we would do it. We really wanted to go faster. So 50 milliseconds is what we chose, 25 milliseconds one way, or about 25, 30 feet, about 30 feet away, so talking to somebody across a large yard. Right now, we have that coverage for 3.1 billion people, right? Leveraging data centers from many different providers. And we can keep expanding that as far as we need. As we add clients and as we add people around the world, we just continue to expand that. And they're linked through many different mechanisms, right? We have them linked through public internet. We have sort of direct connections. We also have one node is on Starlink. I don't know, it's not listed on here, but we actually have a Starlink node that our COO set up. So we have SignalWire is on Starlink right now. You can get to it. It's very exciting, right? So we're trying to push the boundaries how all of these things all tie together. And then we optimize, we optimize by location. Now, this is kind of what we do right now. We use a lot of the tools that Fred was just talking about too. Well, Anycast to GeoIP location, a bunch of other tools to make sure that we can actually get you to the closest thing. We see how far away your connection is, right? We see real time. That's what that text at the top there is kind of mangled into the slide. What we do is expose that contextual information that's currently unavailable. Things like how far away are clients from each other, sort of, in terms of latency, to try to maximize and minimize that for all of them and maximize the experience. And we call that our location-aware optimization. And going forward, what we're doing is working on a lot of different things. One of these is some machine learning techniques, right, where we take in different aspects of the network conditions. And these are things that we are learning. Anyone here who has done machine learning or has really worked in that data science space at all knows that a lot of it comes down to annotation, data collection, processing the models, really getting a lot of output out of that. So we're working to take our networking and our knowledge of how these things fit together and feed them into models that can help us on the fly determine if a network or a connection is looking a little bit flaky, if someone is having a bad experience just based on previously known conditions, or if one of our trunks, like on our slime mold of the world, the way it's all going, if one of them is just not being utilized as much or has had problems over time. You can use techniques for this. You can use all kinds of algorithms to kind of determine this stuff. Neural networks and learning machines are one other way. When I say machine learning, I mean all of those together, right? It's not just one. It's just the advent of data science as applied to these problems. In this particular case, the dog is network conditions, and the output is customer satisfaction, right? Are people getting what they want? Is it what they need? I hope it is, right? The end of the day, what we want is people to be happy with the usage of these tools, and to help them, achieve their dreams of communicating with people over the internet. Because who hasn't dreamed of that since the days of Dick Tracy? And so, yes, this is the slide that stuff's supposed to go on. We power that with SignalWire Relay, right? It gives that contextual information, the real-time access via WebSocket, global latency because it's connected to the nearest edge node wherever you are. So nothing has to transit across the globe to do anything. I think we're constantly expanding that footprint and moving services further and further out towards the edge. As we, naturally, like most companies, started out more centralized, we keep pushing things out further and further and further. So we really are, walking the walk and talking the talk in that regard. And I want to leave some time at the end here for questions. I know, like Fred, that was about 20 minutes. I think about 9 minutes here for questions. I hope that was interesting for people, sort of a glimpse into what we're up to and how I feel about it. Feel free to take any questions. Thank you all for listening.
Top class, Evan. You used the same template as Fred there, leaving the 9-minute mark at the end. And I'm sure there are questions out there. And so if anybody would like to ask them, they could raise a hand. In fact, I see Ryan has already raised a hand. I'm unmuting you, Ryan. Go ahead and ask your question.
Me and you are going to fight over that mute button a lot. Evan, thank you so much for the topic. And it's amazing to see that I'll try to look in the camera instead of my screen to the right. It's amazing to see that you guys are already connecting with Starlink and new technologies like that. Two-part question. One, what intrigued you guys about getting into Starlink other than the topology of Starlink being in a vacuum and communication latency? And how can people like us really start to take advantage of that? We've started for our customers a long time ago having cellular backups to their primary cable and fiber connections to the location. Yep. And so we're looking into how Starlink can work in that same aspect for people, especially since it offers a lot lower latency and a lot higher connection, and also doesn't have to, work on local backhaul too, right? So if the full local fiber goes down to the cell towers, that's a big deal. So how can we start to take advantage of your Starlink connection and SignalWire?
Absolutely. So the Starlink connections we have right now, right, is just sort of a beta project. So we have one node currently connected to Starlink just as a test demo. And the Starlink connections just came out of beta themselves, right? So we had a few beta access points that we got access to as we wired up to them. We were interested in it primarily for the topology reasons, right? And we see that going forward, it's going to solve a lot of these, like, both last mile issues and redundant connectivity issues for people who are in rural communities or in disasters, things like that. And we wanted to be able to provide somebody who was in a disaster scenario the ability to get onto their Starlink, up to the satellite, and then to some sort of communication system as fast as they possibly could, not having to come back out of Starlink, back down again, back into the public internet and kind of mess around. We were like, wouldn't it be nice, having talked with disaster companies, that if they could have something that was really just like very, very close and salient to what they were trying to do. So that to us was a very interesting thing. We're always interested in any kind of networking interop in that capacity, right? Much of what we do with communications is networking based. And so any sort of new system like that was inherently interesting. And then on top of that, seeing, like yourself, having interesting use cases and scenarios, knowing that if we wired up to it, figured out the problems, right? And some of the issues with the initial Starlink were that as the satellites go overhead right now, the density isn't high enough. So depending on which node you're connected to, your ground station can lose connectivity for a little bit. So, right, like as they're adding more and more nodes, it's getting more and more stable. The latency is going down, and we're watching that to see like when it tips over. But in the meantime, just trying to make sure we interact with it and that you can get to it. So if you want the access to that one, we can stand it up, and we're happy to point you at it. And if you have a Starlink, you can connect to that Starlink and go check out that instance and see how it works and check the latency out. And just know you're going through space. That's pretty exciting.
Starlink Club, really cool.
Yeah.
Okay, thanks for your question, Ryan. Any other questions for Evan at this stage of the proceedings?
In the chat.
It's seeming just a little bit quiet. There's one Afshin jumped into the chat and says, are you using FreeSwitch Commonilio in SignalWire, or is it closed source software?
Oh, that hurts. It's painful. You'd have to ask. Ugh. Be still my heart. We use FreeSwitch and Commonilio extensively, right? Naturally, FreeSwitch is, what we are the primary sponsors of. Like you see, all the work that goes into that is on the SignalWire side. Lots of people contribute, but like we put, we have hundreds and hundreds of man hours, hundreds of commits, all kinds of stuff that goes in there. And we use Commonilio. We use all kinds of these tools, right? And we're partnering with all kinds of people to do it. The proprietary technology we have is related to how we do a lot of this communication in the background, stitching the services together, making the data centers come together, all the, data modeling and routing and all the, the huge ecosystem of stuff that it takes to actually run a global SaaS platform. But the FreeSwitch we run is the FreeSwitch you all use, and it's pretty great. It's an incredibly powerful engine in that regard. I'd recommend checking it out even more if you haven't.
Great stuff. Thank you, Evan. There's another one popped up from Johnny Ritzer in the chat. It says, any thoughts around LTE, private LTE and CBRS? Yeah.
I mean, I think I would love to see more private LTE and sites like that stand up, right? It really, to me, LTE is interesting, but unfortunately is bogged down by a bunch of the legacy. I say legacy. A lot of the decisions made in the 90s with like IMS core technology and stuff like that. For open IMS core, you need that kind of thing, right? A lot of the systems used by telcos are intentionally made to be extremely resilient and a little bit redundant, and don't lend themselves well to being miniaturized into private deployments that are necessarily a lot of fun to hack around on. I think that there's going to be kind of a jump here with the 5G stuff away from, there might be like more open space wireless. It's a little more interesting to me for like local deployments of things. They're backed by simpler services that make it a lot easier to deploy. However, if private LTE stuff takes off and even more like hyper localized LTE takes off, I'd be all for it. I just know that there's a bunch of complications in that. If you want to talk to James Bodie about it, he's a fellow colleague from Britain who has stood up his own company in the not spots of the Chalk Valley in Britain, and just got a grant from the British government to help cover these wireless not spots throughout the country. And he is he'll give you a masterclass on that kind of stuff and all the fun of telco behind it.
I was just looking forward to saying not spots myself, Evan, because it's just a nice thing to say.
It's a great term.
Not spots. Yes, and if James were here, he could talk to you about it at some length and give you the full information there. Okay, all right. Evan, we're coming towards an end of the session. Thank you very much. Will you be sticking around in case people want to ask you further questions in the chat?
Absolutely.